Hello students, I welcome you all on quick solution of All India AIATS test series for JEE Mains 2020 test 01 and dated on 6th of December 2019. Let's take on to the question number 1 directly. Here in question number 1, we have been provided with some graph and the question is, the body is thrown vertically upward, then which one of the following graph correctly represents speed versus time? Here in the first option, the speed decreases continuously. Second option, speed increases then decreases. Third option, decreases then increases. And here it is quite irrelevant, as for a given particular time there are two possible speeds. So clearly I would say, as the body moves in upward direction, its speed will decrease, and yet again after reaching the maximum height its speed will again increase. So option 3 is straight away the correct answer. I will say here our correct answer is option 3. There is no further explanation for that. Now let's see the question number 2. Here in question number 2, a block of mass m is placed on a surface whose profile is given by y is equal to 0.4 x square, where x and y are in SI units and x and y axes are horizontal and vertical respectively. If maximum height above the ground at which the block can be placed without slipping is y is equal to 1 by 10, then coefficient of friction between the block and the surface is, well, here profile of the surface has been given as y is equal to 0.4 x square and the point y is 1 by 10. So from here we can find out 1 by 10 into 4 into 10 will be x square, or x will be 1 by 2 meter. We need to find the slope at this particular point where the block will just be reaching at the state of impending motion. So tan theta there would be dy by dx, that will be 0.4 into 2 into x. Putting the value of x to be 1 by 2, we'll be getting the tan theta value to be 0.4. So now what we can say, along this direction mg sin theta will be acting, and to oppose it along this direction it will be mu times mg cos theta. So clearly mg sin theta will be mu times mg cos theta, or the value of mu will be equal to tan theta, which we already have calculated here, that is 0.4. So this is the final answer for the question number 2. So for question number 2, option 4 is the correct answer. Here in question number 3, three particles each of mass capital M and equidistance from each other move along a circle under mutual gravitational attraction with some constant speed v, the radius of circle. Definitely this will be the arrangement. We can say the mass m will be here, here and here, and they will be forming equilateral triangle. The central point would be the center of rotation. Around each of the particle will be rotating. This will be the radius r that's been given here. What I would say, this mass should be attracted by this one and this one along these two direction. If a is the length of this side, then for us a root 3 by 2 will be the height of this region, and this being the radius r, so clearly r would be taken as 2h by 3, so it will be 3r by 2, or a is root 3r. So force on this particle is g m square divided by a square, that is 3r square. This angle is 30 degree, this angle is also 30 degree, it is cos 30, that means root 3 by 2, and force because of this mass along the direction and this mass along the direction, that is twice. It must be equal to mv square by r. Substituting all this part, we will have this part will cancel out, this square term will cancel out, this 1r will cancel out, and we will have here g m divided by root 3v square will be equal to r. Looking on to the options, clearly option 4 is the correct answer. In question number 4, taking gravitational potential v is equal to 0 at r is equal to infinity, the potential at a point on the rim of a thin uniform disk of mass capital M and radius r will be. If this is the disk of mass m and radius r, surface mass density would simply be m divided by pi r square. What we need to find out is the potential at this point on the rim of the circular plate here. So what we consider, if I'm taking this much part of a circular segment, this distance, let's say small width being dr, this angle I'm taking it to be theta, this distance I'm taking it to be r. So looking onto the symmetry, this is r and this is r, this is theta. Clearly I would say r would be equal to 2r cos theta, or dr is 2r sin theta d theta. I'm just ignoring the value of this negative sign simply because I know I'm taking this much of the width here. Well, now if this is dr, this distance from here to here would be, it is r into 2 theta, so I would write it down as 2r cos theta into 2 theta, this distance. This width being dr, it is 2r sin theta d theta, and the mass of this much of the portion would be, this is the area here, sigma into this much, this is the total mass dm, divide by dm into g, divide by r. R is 2r cos theta with the negative sign. This will be the potential because of this much of the circular segment at this point. So if I now integrate this variation of angle theta from 0 is equal to 90 degree, what I will have here, potential because of all such small circular segment will be calculated at this point. So that will be our final answer. So simply looking onto the option 2r cos theta will cancel out here. So I'm having v is equal to integral of, look upon the options here, it is sin theta d theta and here theta, this is 2 into 2 4, it is sigma into g, this is the negative sign here, this is r, integration of theta sin theta d theta 0 to pi by 2, integral of this much of the portion, just I'm taking this reason to evaluate the integral here, it will be integral of sin theta theta d theta by the method of the integration by part. I will have here theta minus cos theta plus integral of cos theta d theta, or it is sin theta minus theta cos theta from 0 to pi by 2. Putting the value pi by 2 here, I'll be getting 1, putting the value 0, so I is equal to 1. So clearly potential at this point is, integral of this much of the part is 1. I'm having here minus 4 gr, sigma, well here's the value of sigma, this is m divided by pi r square, this one will cancel out, I'm left with minus 4 g m divided by pi r. This is the value of the potential at the rim. Looking onto the option, clearly option 1 is the correct answer for the question number 4. Here in the question number 5, from a uniform circular disc of radius r and mass 4m, a small disc of radius r by 2 is removed as shown in figure. The moment of inertia of the remaining disc about an axis perpendicular to the plane of the disc and passing through the center of the disc is. What we need to calculate here, this was the original disc, I would say, of mass 4m. r by 2 radius has been removed, so removed portion shall have the mass of capital M here. Original moment of inertia about this point, we know it will be total mass into r square by 2. So I would say it is 4m into r square by 2 would have been the total moment of inertia of whole of the portion here. So moment of inertia of remaining portion must be plus, must be the moment of inertia of this much part. So this much portion, the mass is capital M, radius being r by 2, it will be r square by 4 divided by 2, moment of inertia about this axis, and plus mass being capital M, and this distance being r square by 4. So I would say 4mr square by 2 minus mr square by 4 plus mr square by 8. It will be 3mr square by 8 would be equal to I of the remaining portion about this axis. So multiplying by 4, this is 16 minus 3. I am left with 13 mr square divided by 8 is the moment of inertia of remaining portion. For the question number 5, option 1, 13 by 8 mr square is the moment of inertia of the remaining portion about this central axis. That's the answer.